today I am going to talk to you about the emission norms that are prevailing in different parts of the world and also in India, and how do we try to meet them. Okay. So, I think the most important thing that we should realize is that we no longer need the proof that the emission coming out of the vehicles is making people sick and it is killing the people in a slow death. It is a proven fact that the pollutant and pollutants, different types of pollutants and harmful species that are coming out are having serious impact on human health. In fact, the World Health Organization WHO has classified the particulate coming out of diesel engines as carcinogens. In 1992, the classification was probable carcinogens. That means they were not sure, there were indications that it is carcinogenic, but recently the classification has been changed to carcinogenic. What it really means is that now they have conclusive evidence, experimental evidence, that the particulate matter is causing cancer in humans. So, in order to control the emissions coming out of the engines, different emission norms or emission legislations are adopted worldwide. When you say emission norms, what do you really mean? Emission legislation. As you know, legislation means law. Okay. So, the emission legislation means a law which deals with the emissions coming out of the vehicles or from the engines. So, what essentially it means is that if your engine is emitting more emissions than the limits prescribed by the law, it is illegal and you are not allowed to sell that vehicle in the market. This is particularly applicable to new vehicle sales. Okay. Later on, of course, the performance deteriorates as the vehicle or the engine gets older, and of course, you get out of the emission window. So, now this fact has also been realized by the emission legislation agencies, that it is not just essential to enforce the emission limits while the vehicle is new. It should also be, we should also make sure that the engine is not polluting during its entire lifetime. And that is why there are vehicle inspection and maintenance programs, and of course, there are many certificates of pollution under control, PUC certificates, that are to be taken in this country also. Of course, it is another matter that it is a joke, you just pay money without testing, you get the certificate, but the intention there is that you take your vehicle to a PUC certification center, and then the mechanics there will assess your vehicle and check whether the emissions are out. If they are out of the prescribed limit, they will tune the engine, they will bring the emissions within the prescribed limits, and then they will issue you a certificate. So, government has also realized that the PUC certification program that is right now going on in India is right now not very effective, and therefore, a new regime of PUC certification will soon be implemented in the country. Okay. So, if you look at how we implement the norms, there are many emission norms in different parts of the world. For example, in Europe, we have norms which are called Euro norms. In United States, we have norms which are called US EPA norms. EPA is Environmental Protection Agencies. In India, we have Bharat Stage 1 or Bharat Stage 2 BS norms. Okay. Right now, we are in Bharat Stage 4. Okay. So, I think these emission norms were first time introduced around 1970s in California, when it was realized that the vehicles are causing a lot of pollution. So, it has already undergone an evolution of close to 45 years or so. In India, the first emission norms were implemented in 1992. So, 1972 in US, 1992 in India, and first time two-wheeler emission norms were enforced. Okay. So, in the beginning of these emission norms, we were lagging by 20 years. So, this was not just the lag in terms of emission norms, this was also a lag in terms of vehicle technology. So, slowly with time, we have caught a catch up game, we have played a catch up game in the emission norms, And now I think from the developed world, we are not really far behind, we are about 5 years lag from the developed countries. I will discuss all those things later in this lecture. So, if you want to measure what kind of norms are to be implemented, say for example Euro norms, you have to run the vehicle or the engine in a particular cycle. These are called driving cycles. So, there are steady state cycles and there are transient cycles. Steady state means that you have fixed load and speed conditions, and this is more applicable to engine testing. Okay. Transient cycle means in a vehicle load and speed is all the time changing. So, transient cycle means the changing load and speed conditions. I will show you what this means. And then with the implementation of Euro 4 and Euro 5, before up to Euro 3 we were able to meet these norms by combustion optimization for both for gasoline as well as for diesel engines. But since Euro 4 and Euro 5 have come into force in the rest of the world, it has become essential that combustion optimization is not enough. You have to deploy some kind of exhaust gas after treatment technology for controlling the particulate as well as NOx emissions from the engine. So, people have used diesel oxidation catalysts, particulate traps, selective catalytic reduction techniques, lean NOx traps. So, many different types of technologies for controlling different emission species have been implemented in order to meet the stringent emission norms Euro 4, Euro 5 and Euro 6 onwards. Similarly, in US there is a US EPA norm, and in India we have BS norms. Now, let us look at what are these species that really we want to regulate, or what is covered in the emission regulations, what is not. So, regulated, when you say regulated species, you are essentially talking of 4 important species mostly. These are NOx, PM, particulate, NOx is oxides of nitrogen, and then hydrocarbons and carbon monoxide. So, when you say hydrocarbons, it is essentially a mixture of hundreds of different hydrocarbons. Everything put together, I told you, either in the form of C1 or C3 or C6, that is hydrocarbon. But when you look at each of these individual hydrocarbon species and their concentration, that is not controlled by the law. So, therefore, they are called unregulated species. So, the unregulated species of which are important are the following: formaldehyde, benzene, toluene, xylene, very nasty chemicals that come out of the engine exhaust, this is called BTX, aldehydes, sulfur dioxide, carbon dioxide, methane, and many more. This list is really an endless list, but we really focus on very few, and I have not given here polycyclic aromatic hydrocarbons, PAHs. Then there is nitro PHs. PHs are toxic, nitro PHs are 100 times more toxic. Okay, so PHs and nitro PHs, very small concentrations can be really very bad. Now, one of the major difference between these two species is that if you look at the regulated species have if you are exposed to regulated species, you immediately feel the pinch because they are in large concentrations. Okay. So, you immediately feel that something wrong is happening with you, but the moment you get out of that environment, polluting environment, the effect also goes away. Unregulated emission species on the other hand are in very small concentration, and you do not feel anything if you are exposed to them because they are anyway in very small concentration. But when you are exposed to all these unregulated emission species for a sufficiently long period of time, you develop nasty diseases. So, unregulated emission species are actually very bad for human health. Now, let us look at overall, if you look at the engine, how much pollutant is really coming out, what is the volume fraction. So, if you look at the emission formation, there is fuel and there is air, and then it burns, combustion takes place in the combustion chamber, and then pollutants come out. Now, in the air you have 79% nitrogen, it is 78% plus 1% argon. So, you include everything into non-reacting species, that is why we say 79% nitrogen, 21% oxygen. Okay. So, when the combustion takes place, nitrogen will anyway not participate in the combustion. So, when it comes out, I think the products of combustion will include nitrogen because it does not participate in the combustion. So, whatever is coming in will go out. CO2 will be produced because there is a hydrocarbon fuel that you are burning, and then water vapor you will produce. And after this, whatever is left, whether it is oxides of nitrogen or whether it is carbon monoxide, hydrocarbons, everything else is clubbed as pollutant species. The volume fraction of this pollutant species or this emission species that we are talking is less than 1% of the engine exhaust. That is what we are talking about. And out of that less than 1%, most of these species are regulated species which we try to control. And these species are very, very small concentrations, few ppm, 10 ppm, 20 ppm. These are dangerous levels actually for some of these species. So that's, this is just to put things in perspective of how much pollutants we are talking about. So I told you about steady state cycles and transient cycles. So you see this is these are the this is European load response cycle and this is European transient cycle. So I would just like to explain this to you. So here you see on the y axis you have normalized engine speed, and here you have the engine torque, okay, and this is the time. So this cycle is from 0 to 1800 second, which is about roughly 30 minutes, okay. And you see here that the speed, this is the rated speed. So suppose rated speed of the engine is 4000 rpm. So now the speed is changing, but at the same time the load is also changing, okay. So when you change both load and speed very frequently, this is called transient cycle. So European transient cycle, all these are values are fixed. So obviously if you have to change both, you cannot do it manually. So if you have to do this ETC cycle, you actually put the controls to the computer, and then computer varies the load and speed both together, okay. Manually doing this, implementing this cycle is very, very difficult, or rather close to impossible. Similarly, if you look at the load response cycle, you have this normalized load and normalized speed. So there are three speed norms. One is A is about 40%, B is about 60%, and C is about 80-85% speed of the rated speed. And then you see here, this is the normalized engine load. So you start the engine very quickly, very high speed, 100% load and 100% speed, and then you reduce the speed and you reduce the load. Then you maintain the load while the speed remains constant, and then you increase the load here for 10 seconds, then you bring it down again, then you again increase the load, then you again increase the load. So you can see here this is sudden increase in the load and this is ramping down, okay. So these are fixed. So let me also talk to you about the stationary cycle, okay. This is called European stationary cycle. Normally this is done for the engines, and I will then tell you why we need to do this, why we need such complicated emission measurements. So you see this is the speed here. So this is the idling speed, 50%, 75% and 100%. This is the load given here. Point number one means we start the engine at this speed at no load, okay. From there we take the engine to about 60% speed, 100% load, and then from there we come to 80% speed and 50% load. From there we go to 0.4, then 0.5, and that way we complete this cycle. Point 13 is here. Now you will see that each of these points have a circle of different diameter, and there is a different number written here. For example, bigger is the circle, bigger number is given, 15%. What does it mean? So now I will come to tell you what is this driving cycle and why do we do it, after having introduced what is the cycle. See, if you are running an engine or a vehicle, if you look at the emission norms, they tell you that okay, you cannot emit more than say 0.2 grams of NOx per kilowatt hour, right? If they say 0.2 grams per kilowatt hour. Now if you are a design engineer or a engine designer, what load and speed you would like to meet that number? you have no answer. Suppose you say that okay, I will meet this number at the rated load because that is where I have my emissions are normally very low. Okay. So, if that is the case, then it does not really give you a representative emission because you hardly operate the engine at rated load and speed, and then all these automotive engineers have hired very brilliant guys like you. So, what they will do is they will optimize and tune the engine to give minimum emissions at that load, and at other load and speed the numbers will be higher. So, when the engine is implemented in the field, it will be polluting engine, but it will pass all the certification tests. Okay. So, in order to avoid that, what is done is that you now run the engine on different loads. You see here loads are varying and speeds are also varying. So, what you do is you measure the emission at all these points, but you need one composite number, right, NOx of this many grams per kilowatt hour. So, what you do is that whatever emission is coming out here, you multiply it by 0.15 plus you multiply by 0.08 plus you multiply it by 0.1 plus you multiply it by 0.1 plus you multiply it by 0.05. When you do all this if you add all these numbers, this is 100%. So, you get one composite number which will include the effect of each and every point. So, now the design engineer which was tuning his engine or her engine only for one load and speed will be forced to tune for the entire load. So, that means when the engine goes into the field, it will not be polluting because almost the entire load speed combinations have been taken into account, right. So, this is why there is a need of driving cycle. So, whenever we say emission norms, so this is how we are going to do for the stationary cycle. Now, you can ask me this question that if this is the case, then how am I going to measure this, because this is going to be extremely challenging, right. I have to come up with one number, right. So, if you remember when we discussed the emission measurement equipment, I showed you about CVS system, constant volume sampling system. What was the CVS system? So, CVS system, now this engine is operating, you have an exhaust pipe. So, this driving cycle is 30 minutes. So, as soon as you start driving the engine under this cycle, it will draw the sample and it will start filling this in a plastic bag which was already evacuated. So, at the end of the 30 minutes, the bag will become full and it will have emission formed at each load and speed and even transient conditions, right. So, now what I have to do? I have to do just one measurement from that bag and I will have my number, isn't it. So, this is how you do the measurement in transient cycles. Okay. So, I hope you have understood how the emission norms are made and how the measurements are done. Is that clear? So, now you see I will show you the emission reduction strategies, because many of you will go to the automotive industry where your job will be to meet the emission regulations. Okay. Emission regulations are becoming more and more strict by every day. Okay. So, first strategy is that if your engine is not a EGR engine, then you put a EGR plus trap, soot trap. Second strategy will be that you put exhaust gas after treatment for NOx. Okay. And then third strategy will be that you go for EGR plus trap plus after treatment for NOx. Okay. So, in strategy 1, when you put EGR and trap, what you are essentially doing is that by putting EGR, we know that EGR is going to reduce only the NOx emission. So, we are reducing the NOx emission by EGR. So, NOx reduction with EGR is done by, then once you put EGR, you know that you will be forming lot of particulates. So, that particulate reduction is done by this trap. So, this is one simple way, easiest way to meet Euro 4 or maybe possibly Euro 5. The second strategy will be that you do NOx reduction with exhaust gas after treatment. So, you employ some kind of a NOx after treatment technology. Two main technologies are there. One is called SCR, which is nothing but selective catalytic reduction, where you use urea to generate ammonia. You break down, you hydrolyze the urea and break it down into ammonia and water, and ammonia is a very strong reductant. When ammonia reacts with the NOx, it converts it to nitrogen and water. Okay. So, that is one system. The second system is the lean NOx trap system. Okay. So, I will discuss maybe in my next class briefly about these systems. Then second system is that since you have NOx control by exhaust gas after treatment. So, what essentially you can do is you can run your engine as hot as possible. That means I told you that you can actually put in your combustion strategy such that engine is running hot, and when the engine runs hot, there will be obviously lower particulate formation inside the combustion chamber, but there will be more NOx formations. You do not worry about NOx because anyway you are going to kill it by after treatment system. Okay. So, this is the second strategy, and third strategy will include everything. You have EGR, you have soot trap, and you have NOx after treatment. Using this you can meet Euro 6 fairly easily, or even Euro 7 for that matter. Okay. So, it is once you combine everything, it is piece of cake. So, so we know that we have to meet the emission challenges. This is one of the biggest challenge that the automotive manufacturers actually face today. So, if you want to meet the emission challenges, what all handles you have got, what all changes you will be required to make. So, first thing is that you have to make a huge change in the fuel system. So, right now you must have seen that earlier diesel engines used to have mechanical fuel injection system, then there were rotary fuel injections, inline systems, rotary systems, high pressure systems, and then came electronic fuel injection, then finally CRDI. So, in this process of evolution of injection systems, all the way we have from most inflexible mechanical system right now to most flexible CRDI system. So, this is one area that will give you a lot of handle to control the emissions. Second is that you can do variable valve actuation. So, that means the valves are opening and closing using solenoid. This is called VVT, variable valve technology, okay, which is coming in right now in very high end cars, but as the solenoids get cheaper, controls get cheaper, I think in 5 to 10 years time, even in cheaper cars this will be available. Okay. Of course, turbocharging gives you a lot of handle because it reduces emissions, it gives you more power. Okay. I have discussed this in detail. There is a EGR system, so you circulate a lot of exhaust back into the system, that also controls the emissions. Then you have intelligent control. Intelligent control means basically use of ECU and a lot of programming, calibration system, engine calibration, and then you use clean diesel fuels and clean gasoline fuels. You employ a lot of sensors, and you have these PM filters, NOx absorbers, after treatment technology essentially. So, you have to take basically, you have to look at all the factors that are possible in an engine in order to meet the emission challenges of the future. Okay. So, you have to basically control the formation of the pollutant in the cylinder by controlling the air handling system, by fuel handling system, electronic control systems, and after treatment system for PM and NOx reduction. Now, this is just I want to show you some global trends, and then we will discuss. Just look at the trends, global trends in light duty diesel PM control. Light duty vehicles, okay. Light duty vehicles means something similar to the cars, okay, cars and SUVs. These are light duty vehicles. Heavy duty vehicles are like trucks, okay. So, you all know this. So, if you look at the PM, this is PM given in grams per kilometer. See, one thing you have to understand, the emissions, when you say emission compliance, there are two types of units that are given. One is grams per kilowatt hour. So, grams per kilowatt hour means the testing has to be done on the engine dyno, because engine is going to produce some power. How much power it is going to produce will be known to you via a dynamometer. So, then the units are corresponding to kilowatt hour, grams per kilowatt hour. Emissions are in grams, kilowatt hour is the power produced. So, per unit power produced by the engine, how much emissions you are going to put in. If the units are grams per kilometer, that means you are testing the whole vehicle, because in the vehicle you never know how much power is being produced, but the vehicle drives. Okay. So, this testing is not done on a engine dynamometer, this testing is done on a chassis dynamometer. Chassis dynamometer really means that you have an entire vehicle, there is a big room like this, and then you have a vehicle, and that vehicle is standing on rollers. Okay. And when the vehicle, you put the gear and you start the vehicle, the rollers also start rolling. Okay. So, of course, you have to tie the vehicle very tightly with ropes, so that in case the roller gets jammed, it should not run away. Okay. So, you make all the safety provisions, and then you have to blow the air. So, big fans are required, because the vehicle should experience the same conditions as it experiences in the field. In the field you have natural draft, because the vehicle is moving fast. Inside a room there is no draft, so you have to create some artificial draft. So, vehicle remains stationary, wheels are rolling, and there is a big draft of the air that is given to the vehicle. Okay. So, if that is the case, if you are doing the testing on the chassis dynamometer, then the units will be grams per kilometer. Okay. So, here you see different emission norms are compared. For example, this is tier 1 norm, this is tier 2 norm, this is low emission vehicle, this is ultra low emission vehicle, this is super ultra low emission vehicle. Okay. And this is Japan emission norm for 2002, this is Euro 3, and this is Euro 4 for particulate for light duty vehicles. So, the trend is that with time the particulates are being controlled quite heavily. Similarly, trends for light duty NOx control. So, these are the petrol vehicle as well as diesel vehicle. Petrol is in the red and the diesel in the yellow. You can see this is also in grams per kilometer, this is 0.9 grams per kilometer, and you can see the same trends. Okay. The Euro 3 to Euro 4, it is going down, and this is comparing different types of emission norms. Similarly, heavy duty vehicles, you see this is the particulate given grams per kilowatt hour. Okay. And here you see this is for the European Union, and this is on this axis you have a journey of about 20 years on this axis. So, this was allowed in 1993, 0.4 grams per kilowatt hour, and this has really come down to 0.04. So, that means in less than 20 years you have reduced the emissions to a level of 10%. Okay. Similarly, this is for the US, and this is the proposed one for the US, even more stringent. Okay. Of course, this is a little old slide, so proposed is no longer valid. Okay. This is the EU buses. So, essentially the point that I want you to make is that with the time the emission norms are getting more and more stringent, and this is for the NOx, heavy duty vehicles, NOx emissions. Here also the same trend you can see. Now, question is that NOx is going down, PM is going down, and we know that if you want to control NOx, the PM goes up, if you want to control the PM, the NOx goes up. How do you control both of them? So, it is quite challenging. So, by some examples I will try to explain how people have attempted this in the past, and if we learn the past well, we will be able to deal with the problems in the future in a similar way. So, emission reduction strategy and heavy duty standards for 1998, 2002, 2004 and 2007 US norms. So, this is US EPA 1998. So, it was allowed to have particulate emission of about 0.1 grams per kilowatt hour, and it was allowed to have NOx emission up to 4 grams per kilowatt hour. This is 1998, about 20 years back. Okay. So, this is where we are, and obviously as the emission norms get tighter and tighter, you have to move closer to the origin. That is your journey path. Okay. This was the envelope for US EPA 1998. When we implemented the US EPA 2002, this was the envelope. Okay. 2004 which and 2002, 2004, and this was the US EPA 2007. So, you can see what kind of stringent tightening was done. So, from here to here one could move by reducing the sulfur level to 350 ppm. Okay. Combustion system optimization, high pressure fuel injection system, cooled EGR, and from here you know 2004 you have to come to 2007 levels, which is very, very small. Okay. So, from 1.1 you have to come to 0.01. and from 2.5 you have to come to 0.025, okay. 10 times NOx reduction, 10 times PM reduction in a period of 4 to 5 years. So, how it was done? So, it was done by using particulate filter. So, when you do particulate filter, what are you going to reduce? PM, but NOx remains the same. So, from here you came here, and from here you put denox system. So, you came here, okay, and that is how you could reduce the NOx by 90% and PM by also 90%. Of course, it required lot of changes, including reduction in sulfur levels for the fuel, in the fuel. Sulfur in the fuel is very important factor. Sulfur is good and bad both. Let me tell you the bad part first. So, sulfur is responsible for formation of particulates. How does it work? Sulfur gets converted to sulfur dioxide gets converted to sulfur trioxide in the hot environment of the combustion chamber. Then you have moisture formation, so you have H2SO4 vapors, they react and they form sulfates. Sulfate is the nuclei for particulate formation. So, if you want to reduce the particulate formation, you have to remove the sulfur. So, if you just reduce the sulfur, you can control the particulates. But unfortunately, reducing sulfur is very challenging, it is very expensive. You have to make a huge investment in the refineries in order to reduce the sulfur, just one sulfur component. Okay. Sulfur compounds are also called thiocompounds. So, if the sulfur compounds are present in the fuel, they give lubricity properties to the fuel, and you know that fuel injection pump and fuel injectors, they work under very high pressure. How high pressure? Now it goes up to 1600 to 1800 bar, and there is no lubrication system. It is the fuel which acts as a lubricant as well. So, if the lubricity compounds are removed, fuel essentially loses lubricity, and if the fuel loses lubricity, what it means is that your fuel pump and fuel injector will wear out faster. Okay. That is why if you are reducing sulfur, emission norms require that you should remove the sulfur, but if you are reducing the sulfur, it is also going to reduce the lubricity. Therefore, you have to add some kind of additional lubricity additives to the fuel, which is a cost, additional cost. Okay. So, so this is one point that you have to keep in mind. If you look at the basic engine technologies that are used for emission reduction, first is the combustion optimization. Okay. Second is 4-valve technology. So, earlier there used to be only one inlet, one outlet. Now there are 2 valves, 2 inlet, 2 outlet. Gas exchange becomes more efficient, that also helps you reduce the emission. Then optimization of the combustion chamber air motion, because air motion inside the combustion chamber affects the fuel air mixing, and fuel air mixing affects the particulate formation and also NOx formation and also other pollutant formation. High pressure fuel injection pressure such as common rail and unit injectors. So, these two systems also employ very high injection pressure. Common rail you can go easily up to 1600 bar, unit injectors you can go up to 2500 bar. Higher is the pressure, smaller will be the droplet size of the fuel that you are injecting in the combustion chamber. Smaller will be the droplet size, there will be mixing of the fuel and air will be better, and if the mixing of the fuel and air will be better, delay period will be smaller, combustion will be more efficient, therefore, the pollutant formation will also be relatively lower. You can retard the injection timing to reduce the emissions, you can use EGR, you can use turbocharging, you can do electronic control of the injection, you can this is repeated. You can use gasoline direct injection technology, you can reduce HCCI technology to control the emissions. We have all discussed this in detail. And on top of it, you can use cleaner fuels such as compressed natural gas, liquefied petroleum gas, biodiesel, ethanol, methanol, dimethyl ether, and ultimately hydrogen in order to control the emissions. So you have a host of things that you can do in order to control the emissions from the engine. Again, this is also a very historic slide which shows the same particulate on the y axis and NOx on the x axis, and you can see the numbers are really very large, but just to show you how things have happened. This is 1988 level, this is Euro 1 level, this is Euro 2 level, this is Euro 3 level. you have to move in this direction, but when you move in this direction, you have to introduce newer and newer technologies. So, it does not come without any cost. The complexity of the engine increases, the cost of the engine also increases. For example, from here the turbocharging was done. So, you came here. When intercooling with turbocharging with intercooling was done, you reduced further. When electronic control of the fuel injection system, you reduced further. When you reduce the fuel sulfur, it reduced further. When you reduce the lubricating oil consumption by optimization of the rings, etc., this reduced further. When you optimize the combustion, this reduced further. Then you introduce EGR, pilot injection, catalyst, etc., it reduced further. So, basically you can see that although you are able to reduce the emission to meet the emission norms and reduce the pollutant emission from the engine, but it also increases the complexity and cost of the engine. Nothing is free. Again, this is also a similar type of graph. You can see, but this is one more extra information. This is particulate on this side, NOx on this side, and here you also have brake specific fuel consumption, and that is what most people are most interested, right. So, if you look here, this is Euro 3, this is Euro 4, and this is Euro 5. Okay. So, here you see this is the measured data for optimized combustion 2 liter per cylinder class of engine without EGR. Okay. So, you have to basically come here. So, first you are here, you want to come here, and then you want to come here, finally you want to come here. Okay. This is US 2007, US EPA 2007, this is even more stringent than Euro 5. So, what you do is you can operate here, you can operate the engine here, you can operate the engine here. So, you operate the engine at very high temperature, so that particulates are low and NOx is high, and then from there what you do is you put SCR. So, if you are using 65% efficient EGR, you come here. If you put 80% efficient EGR, you come here. Okay. This is measured data with cooled EGR without trap. So, if you are using with EGR, but without trap, you operate here, and from here if you put trap, soot trap, you can come here. So, you can see these are the two methods. One is that you run the engine hot, then you put the SCR, and depending on the efficiency of the EGR, you can either be meeting Euro 4 or Euro 5, or you can first use the engine with EGR. This is without EGR, this one is with EGR. Use the engine with EGR and then put trap, and then you come here. Okay. But if you look at the meeting emission norms is fine, but you are also interested in economy. So, let us look at the economy. So, when you are operating the engine in a hot manner, you are actually burning all the soot, and hot engine means higher thermal efficiency. So, lower fuel consumption. So, you operate here, and SCR actually does not consume any energy. So, you are operating the engine at close to 195 grams per kilowatt hour fuel. Okay. When you are operating the engine with EGR, EGR has some fuel penalty. That means you control the NOx emissions, but fuel penalty is there. And when you put soot trap, soot you are burning outside, so it does not affect the efficiency. So, at that time, using this strategy, you are operating the engine as 210 grams per kilowatt hour. So, essentially the difference between these two is 15 grams per kilowatt hour. 15 grams per kilowatt hour essentially translates into about 10% or 8% better fuel economy, right. So, the advantage of using EGR and particulate filter is that very low particulate emission can be achieved using particulate trap. But the technical challenges are that you need EGR compatible combustion system. Now, what does it mean? It means that you are forming particulates. Some of the exhaust goes back into the intake. If you do not remove the particulate, those particulates will go into the intake system. They will go into your combustion chamber. They will stick to the cylinder walls, and they will come in between the piston ring and the liner, and that will cause contamination of the lubricating oil, that will cause wear of the engine. Okay. So, you have to clean the system. So, you have to make the EGR compatible combustion system. You need a robust recirculation system which can control the EGR very precisely. Right now, in most of the Indian cars, it is either EGR on or off. Okay. In some conditions there is no EGR, and when it is on in fixed quantity. You can't really vary. However, if you really want control, you should be able to vary the EGR 1%, 2%, 3% going all the way to 15-20%. But this kind of fine regulation also requires very sophisticated valves which increase the cost. Okay. So, you exact dosage of the EGR, you will be able to optimize your system better. Minimum transportation loss from the exhaust to the intake. You need durable and insensitive control. Insensitive control means that if there is deposition etc. in the EGR system, it should not affect the quantity that is going in. And then you need durable particulate filter with reliable generation. You need to definitely put a particulate filter before the exhaust is sent back. Okay. So, you need a system which is durable and you can regenerate it very quickly, effectively actually. Now, India, as I told you, started on its journey of emission control. So, what was done initially in this, I am talking about period around year 2000, 1992 we started, and by 2000 it was fully clear that we have to go all steam, full steam. So, we implemented on 2 and 3 wheelers. So, for 2 and 3 wheelers lean fuel air ratio and electronic ignition was advocated. Earlier there were just carbureted system, in even now some of the vehicles are available with carbureted systems. Air fuel improvement in the improvement and also the improvement in compression ratio, improved combustion chamber design, then better scavenging. You know what is scavenging? So, scavenging is normally a 2-stroke phenomenon. So, 2 strokes are anyway phased out. So, this is not really very relevant now. Reduced oil to fuel ratio, then change over to 4-stroke engine. This I am talking of 2000. It was mentioned at that time that 2 strokes have to be phased out slowly. Now, we have not even a single 2-wheeler being sold in this country which is a 2-stroke engine, all are 4-stroke. And then use of catalytic converters. Now, all 2-wheelers are equipped with catalytic converters. Then electronic engine management system have also come into the most of the engines. There will be some kind of a small, very primitive ECU, but it has come, very cheap ECU is put in. Then most of the engines now have fuel injection systems. Then 4-stroke engines with catalytic converters. For the petrol passenger cars also different options have been done. For example, optimized air combustion and ignition timing control has been done, catalytic converters have been introduced, positive crankcase ventilation system has been introduced, evaporative emission control system. Positive crankcase ventilation means that when in the gasoline engines the fuel air mixture is compressed. So, when the piston is going up, some of the fuel air vapor escapes to the crankcase, and then crankcase is not airtight. So, there is a dip rod and there are many places from where it can escape. So, if it escapes, hydrocarbon is going into the environment. So, what is done is that you have positive crankcase ventilation system. So, that means the escaping emission will go back to the intake, so that it gets another opportunity to burn inside the combustion chamber. It is not allowed to go into the environment. Evaporative emission control system means that whenever you fill the tank, tank is empty, it is actually not empty, it is filled with vapors of the fuel. When you fill the liquid, vapors go out. So, can you capture them? And it is not really insignificant quantity, it is about 2 grams of the fuel that goes out when you fill your car. Okay. So, can you capture it and use it again? So, that is called evaporative emission control system. A potential technology includes 3-way catalytic converter with fuel injection and lambda sensor, which is implemented in most of the systems, converters with improved cold start performance, onboard diagnostic system and electronic fuel management systems. For diesel vehicles, turbocharging and aftercooling or intercooling is done. combustion optimization is done, reduced oil consumption through engine design improvements is done, higher injection pressures are being employed, better fuel spray patterns are also being employed. So, now Indian OEMs have also understood the importance of spray optimization, then retarded engine timings, electronic engine management systems, EGR, oxidation catalyst, particulate traps, and finally NOx catalyst. So, particulate traps and NOx catalysts are still not introduced in India in most of the vehicles. Some vehicles may be there, but in times to come, once we implement Euro 6 in April 2020, we will definitely require both of them. Okay. So, if you look at the regulated emissions and long term exposure problems, this is, I have already told you that CO emission is more evident in the petrol engines because you are having stoichiometric combustion. Long term exposure can prevent oxygen transfer in the blood because the hemoglobin gets converted into carboxyhemoglobin, which is a very stable product, and you can actually die if you inhale carbon monoxide too much. And if you have small exposure, you have nausea and headache. Okay. Hydrocarbon emissions are again main problem from the petrol engines. This also causes headache, vomiting and disorientation. Okay. If you have NOx emissions, they are more prevalent in diesel engines, also from petrol engine, but more prevalent from diesel engines, and their exposure can cause nose and eye irritation and damage to the lung tissues. Okay. Because NOx NO2 reacts with water, it forms nitric acid, whatever weak nitric acid it may be. So, it creates a lot of problems. Particulate emissions also is the main problem from diesel engine and also from GDI engines, gasoline direct injection engines. Okay. They can harm the respiratory tract and also reduce the functionality of the lungs. Okay. So, Bharat stage norms, they were first introduced in 2000. They are the emission standards that have been set up by the central government. When you say central government, essentially CPCB, Central Pollution Control Board, to regulate the output of the air pollutants from IC engine equipment, including the vehicles. Different norms are brought into force in accordance with the timeline standard set up by the CPCB, which comes under Ministry of Environment, Forest and Climate Change. Bharat stage norms are based on the European legislation. So, basically they are nothing but copy of European norms, except that in Europe the driving cycle goes up to 120 km per hour. For the BS norms, it goes only up to 90 kilometers an hour. Why? Because in Europe, you can drive at 120. So, it is more representative for them. In India, where are the roads except now? There are no roads where you can drive 120. Of course, with time, we will change that also, because in India also now roads are improving. Now you can do 140. Okay. So basically India is one country where we have split our country into two emission regulation zones. One is that we say that there is a set of 13 cities where there will be a different emission norm, where we do it on an experimental basis, and then we have the lower emission norm in the rest of the country, and then slowly the rest of the country catches up. The reason why we did it, that suppose you change from Euro 3 to Euro 4 all of a sudden. So, the oil marketing companies have to make available the oil also Euro 4 fuel in one go, which is a logistical nightmare. So, what they do is they introduce in 13 cities, and they provide the fuel Euro 4 to them, Euro 3 to lower norm fuel to the rest of the country, and then within a year or two they develop all the capacity and slowly phase out the Euro 3 and then go to Euro 4 and likewise, right. So, that is the idea. So, Bharat stage 4 was implemented in 2010 April in 13 major cities, and in the whole country it was effective since April of 2017. So, this gives a time of around 7 years for the vehicle manufacturers and also the oil companies to basically clean up their act, if I can put it like that. Okay.